In this presentation, we will discuss a situation in which we have data from several languages in our dataset. This is something that is not uncommon in linguistics or cognitive science. And it is of course clear that we can't simply build a model for some dataset that contains only expressions from, say, Finnish, and then expect that the same hypothesis would work with data from English. So the question is, how can we deal with this situation? And also to do this in a way that is interesting from the point of view of linguistic theory and cognitive science. And these questions will bring us to the quite interesting topics, such as additional topics, such as language acquisition, innateness versus what is learned, the notion of universal grammar, and many other such things. And of course here we have to again translate or transform these notions and all the questions that are involved into the more exact framework. But I divided again this presentation into two parts, so that this part discusses this issue in a more informal way, and then the second part addresses the Python implementation. But let's begin from what I consider to be the simplest way of approaching this situation. So imagine now that we have segments in our dataset, different segments which contain expressions from different languages. Let's say English and Finnish. And the simplest solution is to simply write down completely separate models for each data segment. So we simply begin from the assumption that I want to make a model of Finnish, what is attested, what is possible in Finnish, and satisfy the sufficiency condition. And then I simply build from the ground up another theory or model or analysis for English. And of course, because a lot of actual realistic linguistic work is done in a framework that mimics this starting point, in a sense that linguists in a country like Finland are often incentivized to focus only on their own language, the language that is of the most important concern for the citizens of that language. So they tend to form a kind of a semi-isolated groups that are only serving the interest of the citizens and the native speakers of that language, and rightly so. And the same for English, but English is a global language, so there it's a little bit different, but let's say Italian. And this would automatically lead us towards assuming that we simply create a mathematical model for Finnish language, and that will serve the native speakers and Finnish citizens and population. It will help us address problems that have to do with teaching Finnish as a second language pathologies that concern Finnish patients, and the construction and definition of Finnish vocabulary, the lexicon, and other things. So it's not completely unrealistic to think that different models could be developed for different languages, and all this work would be done in relative isolation. But there are several reasons why we are not really interested in this approach. And this is the approach we will not assume here. I have listed 5 reasons, but there are others, but these are the most important points. So let's begin by going through those. Now, one obvious objection is that even if we had different analyses, grammars, theories, hypotheses which deal with attested patterns in Finnish and Italian, even if we start from that point of view, still the executive layer and the supervision layer don't need to and should not differ. Remember, the executive layer was defined, and actually the implementation was also built from the assumption that the empirical part was isolated from the derivational search function and whatever other functions we would use. And in both grammars, whether it's Italian or English or Finnish, we would have to use the same derivational search function to explore its empirical consequences. And the same goes for the supervision layer. And remember, both of these are very important components of the whole computational infrastructure. And because only the grammar would change, or only the grammar or the empirical part would have differences, this leads us towards at least assuming that we have one model, one executive layer, one supervision layer, and only the innermost core, the empirical part, would be different. So you can see that already on these grounds, it would make sense to develop only one computational infrastructure. That would be a useful starting point. We would then simply change the innermost core. Everything else would remain the same, but the innermost core would be changed based on the language. The second obvious point is that languages clearly share some of their properties. I will give an example at the end of this presentation, but we already discussed binding. Binding concerned how pronouns and pronominal elements and proper name, referential expressions, what kind of references, what kind of co-reference dependencies they can have. And this is something that is true of not only English, but also Finnish and Italian, and the rules are quite similar. So I will show this in the end of this presentation. But even beyond this, think about the assembly operation. So we concluded that languages are combinatorial systems, so there has to be some type of assembly operation which combines elements together. So it simply doesn't make sense to think that the model for Finnish would be completely different in this kind of more fundamental sense than the model for English. They both will rely on several fundamental operations, like the assembly. We could just list other obvious similarities. Let me just go through some. Both languages have things like verbs, nouns, adjectives, adverbs, the distinction between finite and non-finite clause. Both languages, or all these languages, have interrogatives, and interrogatives are formed in a similar way by putting the interrogative word, such as interrogative pronoun, to the beginning of the sentence. All of these languages involve some restrictions which concern interpretation of referential expressions. All these languages have very similar thematic roles. All these languages build sentences around tense and aspect. All these languages involve agreement phenomena between subject and verb. None of these languages create complex constructions by linearizing the sentences from end to the beginning. So that kind of operations do not exist. All of these languages have auxiliary type of elements, support verbs, especially when we are creating complex tense constructions, such as John has been here, for example. And so the list goes on and on. So we see that there are some differences. So it doesn't make any sense to begin from the assumptions that all of these models have to be completely different, even when we go to the empirical part. Then we have a third thing is that we have bilingualism or multilingualism is a natural phenomenon for humans and for our brains and for our species. So a child can acquire native level competence in any number of languages. Of course, there must be some practical limits what is possible, but it's not that we only learn one language or two or even three. We can learn more at the native level. So this means that the human brain, the system that we are ultimately trying to understand here, all of these networks and processes, information processing that takes place, it has to be able to accommodate several languages. So insofar as we are interested in the real human brain and the human linguistic behavior, it makes sense to make the assumption that there is some type of fundamental system, genetically programmed, that is in the human brain, in some sense that we don't know, which provides these basic abilities. Perhaps they are those abilities that underline the linguistic phenomena I just mentioned. Perhaps it's more fundamental. Perhaps it's just some type of more abstract property of the neuronal systems from which all of this emerges when the child is immersed in the linguistic environment. But we know that non-human animals don't have this capacity, even if they are raised in a linguistically rich environment. And if we think about the question in a more concrete sense, so the issue is, how would we create a model for bilingual speaker? So the idea that all of these models are simply completely separate things would somehow mean that the bilingual speaker would, when it shifts from one language to another, would kind of overhaul the whole and complete system, perhaps using neuronal circuits A, and then shifting from Finnish to Italian, simply start using or activating some completely different neuronal mechanism, perhaps in a different location in the brain. But we don't have evidence at all that this is the case. All these languages that the bilingual speaker is using are activating the same, actually they activate the same systems in the brain. And the fourth reason is that when we are considering a multilingual dataset and taking into account the observation that languages seem to have several fundamental similarities, then whatever theory we will end up that tries to explain these differences and similarities, even in the scenario, I come back to this later, where most of the linguistic behavior is culturally determined, so it's acquired and learned from the environment. Let's assume that. Even then, it's not irrational to ask which parts of our linguistic behavior are determined culturally and which parts are not, even if the latter biological component would be extremely small. It's still rational to ask this question: where is this line between biological and cultural factors? And in order to ask this question, we will have to begin from one model where we will attempt, and I explain later how, attempt to find out where this line is. But this presupposes that there is only one model in the beginning, and that one model will have a cultural component which the child acquires from the linguistic environment by learning language or several. And then there's going to be biological component which comes from our genes, is part of the neuronal architecture of the human brain, and is missing from non-human animal brains. And finally, the final and the fifth reason I want to mention here is that we want to understand also language acquisition. So here, as I have been discussing this human linguistic behavior, I have been assuming now that we are working with linguistic datasets that contain attested human linguistic behavior. But framing this question in that way, we have tacitly or implicitly assumed that the system we are describing comes from some kind of mature linguistic capacity or end state. So that the data comes from an adult linguistic behavior after a person has acquired native level. So the question of language acquisition has not been raised before now. But nothing prevents us from considering datasets from child languages. So we could examine, we could compose a dataset from attested linguistic behavior of 2-year-old children and 3-year-old children and 4-year-old children. We could sample their behavior as well. And so that the dataset would contain segments from Finnish speakers of different age groups. Perhaps also individual children, because there are so much differences in the way, or let me say more carefully, because there are significant differences in the speed and the ways we learn or acquire our native languages. Perhaps if we use data from child languages, we would have to take a more individual level approach into the data sets. But be that as it may, we could start from this type of data sets and begin to model language acquisition. And language acquisition, even the question itself, assumes that we have initially only one model. And that model is the biological components that are fixed, or perhaps they kind of emerge automatically as the brain is maturing. We have those components, and then we have some room for variation, which is where the language acquisition changes the system. And then these changes would provide us a series of models. Perhaps in a stages, there are theories which assume that language acquisition proceeds in several more clear stages, or perhaps it would be more continuous. I don't care about that. What we would have is some type of development in the model. And these different models that are created during this development, language acquisition, would then be used to capture these child language datasets. That would be the only justification for them. And so this approach, if we are interested in language acquisition, forces us to consider, forces us to begin from just one model. It just will have the learning component as one of the universal mechanisms. So that already 5 reasons why the idea that every language is analyzed in isolation from each other is not a useful or interesting starting point. And I'm not gonna, so the way how we will approach this question here does not make that assumption. But let's move on. Let's assume now that we are trying to create one model for the reasons I just mentioned, or there are also other reasons. What would we do? Now, obviously, this type of one model will have to have these 2 components in it. There will be a biological component. Imagine it as kind of a general architecture or information processing system that have some basic operations available, neuronal architecture. And it's a part that is not changed. I'm now talking now about the empirical core, because we assume that the executive and supervision layer are automatically identical, and we ignore those completely now. Actually, I want to mention that the supervision layer, if we would be modeling real language acquisition, then the supervision layer would need to have significant additional components to handle all this learning. But I put that aside. The model itself, the one model will have to contain the biological components and then the cultural components. And then the question becomes where the line is. And this is a question I'm not going to answer here, but I'm just going to, by way of illustration, and to making this all more concrete and provide some kind of starting point to discuss 4 alternatives ranging from biologically oriented models into a culturally oriented models. And then I say a few words of each and how they could be implemented. So here we have the 4 approaches. These are not the only approaches, but I picked them here because they make fundamentally different assumptions concerning how the biological and cultural components will be defined. So the first model is a biologically oriented theory and says that only the lexicons are different, and this includes also the so-called functional lexicon. So this type of grammatical particles like tense, transitivity, causative morphemes, prepositions, conjunctions, and other more grammatical oriented words or morphemes or perhaps abstract elements. So in this type of approach, everything else, all the rules, the whole algorithm, the whole model, all the information processing is identical between when we capture Finnish data or English or Italian data, but the lexicons will differ. In other words, when we move in our dataset from sentences in Finnish to sentences in Italian, all we have to do is to change the lexicon corresponding to the language in the dataset. This is a minimal assumption in a sense that it's obvious that languages differ in the vocabulary. And the vocabulary is something that comes from the environment by learning. The second option, this is the so-called principle and parameters approach. So in this model, we assume that the rules, so now we are assuming that the lexicons differ, and this assumption is made in every theory here. So we assume that the rules between English and Finnish can differ. They don't have to differ, but they can differ. But that there is only limited, finite amount of variation. So we can have some rule. Let's take a simple example. We can have a rule which allows finite clause or forces finite clause to spell out overt grammatical subjects. So in English we can say John admires Mary, but we don't say admires Mary. So the John cannot be ignored or suppressed or eliminated from the sentence. But then there are languages like Finnish where you can eliminate the subject. Italian is even more clear example of this behavior. So this would be an example where we could have a rule, let's say a rule which regulates grammatical subjects in finite clauses. And the rule would have two variations. One where the subject is must always be overtly expressed. Another version where it can be where it's optional that it can be dropped or eliminated. So that's what I mean that the rules have finite amount of variation. How to do this? Usually this is implemented by using the notion of parameter. So there is a rule which regulates grammatical subjects, or several rules, but we are talking about the rules, some rule that is relevant here. And then the rule will have a parameter which determines the eventual final outcome of how the rule applies. And the parameter could be, for example, we could call it a pro-drop parameter, which says that the pronouns can be dropped from finite clause. Italy would have this parameter would be set in an on position, and in English it would be off position. And then when we process Italian versus English data, we not only change the lexicons, but we also change the values for these parameters. And the values of the parameters are then stored somewhere in the overall model, empirical model. In the implementation part, I will be looking at the question of how they could be stored. The third option, and now we are moving towards more culturally oriented models, is that languages can exhibit different rules. So the rules themselves can be completely different. In the second version, basically we are talking about single set of rules. We just add a little bit finite amount of variation. I also forgot to mention that usually there's theories in the second category, the assumption is that the amount of variation is really limited. So each rule can have usually two possible variations, maybe a little bit more, maybe three, but usually it's 2 or 4. That's the assumption where this hypothesis, what makes this hypothesis interesting in the first place. But if we go level 2, we are saying that now we can have different rules for each language. We can have same rules still, but it's possible that the rules differ in arbitrary ways. And in this, implementing this type of cultural theory presupposes that the universal part, the common part, will have to have some more general representation medium where we can implement these rules. And when we change from the processing of English to Italian in the dataset, then we change the lexicons, and we load different rule sets, this medium, this representational system in the model will simply load different content. What is this representation medium? It depends on what we think that this rule system is. But it has to be very general in order to create an infinite amount of arbitrary amount of different rules. There could be some kind of, just comes to my mind, some kind of conditionals, for example, like this, that if the sentence has structure A, structure meaning some kind of structural conditions, which can be stated in this notation we decide, this universal rule notation, then do this. And both of these, the antecedent and the consequences have to be formulated in some kind of general notation that is able to refer to the linguistic representations and features and configurations. And then the assumption here would be that the child is inferring, learning these rules from the linguistic environment or the language that is spoken around him or her. So perhaps formulating a rule and then seeing that it doesn't work and then correcting it or formulating a new rule. And so language acquisition then has to be modeled as an incremental process where the cognitive system or the information or the whole cognitive architecture is creating these rules. In the second option, the acquisition is simply the setting of these parameters for each rule. So the child has to decide, it looks the linguistic evidence and it sees that, okay, in my language, the subject is optional, subject pronouns are optional in most circumstances. So it sets the rule into that position. And in English speakers, they see that the subject is mandatory and they will set the rule into activate the other variant. But in the number 3 is in a major way, it's a completely different approach because the child has to create rules and has to have the representational system that can implement these rules. And then finally we have the option 4, which is basically that all linguistic rules are different. Now here to be completely exact here, what I wanted to say is all linguistic rules are different. So languages simply are different rule systems. Number 3 still assumes that there can be universal rules. This is completely culturally based approach. And why it's important here to say that linguistic rules, because linguists who make this assumption, they still assume, and they have to assume, that some more general cognitive mechanisms are universal based on biology. For example, some general learning mechanisms, some general cognitive mechanisms that the child can use to infer and create and test the rules as he or she is learning them. And memory systems have to be universal. So the number 4 is basically claiming that the biological architecture, the fixed part of our model, the genetically based part of the model, the part that will not change under normal circumstances, concerns general cognitive abilities. And all the rules and behaviors that are specific to language, to individual language, are acquired from the linguistic environment. And this approach, of course, assumes 1 and 3. The lexicons have to differ, and then the linguistic, and then the languages must be able to have a representational system for different rules also. Now, let's keep this system now in mind. There are other options, and all of these 4 models allow some room for variation, and they are all represented in the scientific literature. And although I, for example, and most researchers strongly believe that one of these is more truthful than the rest, there is no agreement. So we can't and should not here restrict our attention to one or to one specific solution. And that's not what I'm going to do. Instead, we acknowledge that this is an empirical question. We acknowledge that it's controversial and unsettled. And then the question begins, how can we solve it? And here is the way how we solve it. We assume that we have a multilingual dataset, and we assume that that dataset can have data from any number of languages. And to be realistic, we also assume that this dataset always concerns some more narrowly defined linguistic phenomenon, such as binding. So imagine that we have a dataset where we have data from binding from Finnish, English, Italian, French, Swahili, Chinese, some variation of Chinese languages, Russian, and others. We can imagine that we have evidence from all attested languages, all 5,000 of them. If we want, we can also include dialects and others. So that's what we imagine. And if we first pay attention to the sufficiency condition, then it's clear that if we have all these 4 options available, we can always, and also if we have some technical way of implementing the distinction between biological and cultural components, which will be the topic of part 2. So if we have these 4 options in our arsenal, and we have the technical implementation, we know that we can satisfy the sufficiency condition. Why? Because we can always adopt the solution 4 or even solution 3. If we can't use the same principle or model or assumption to capture English and Finnish behavior, we can always introduce an arbitrary amount of language-specific rules. We will just be changing these rules and lexicons when we are modeling different languages in the dataset. So the sufficiency condition does not create any problems, assuming again that all of these options are available in principle. And why we make this assumption? Because now I'm asking, how do we solve this question empirically in the current framework? And so that question assumes that we don't rule out anything out a priori. Rather, we are finding a way to decide, making a decision between these 4 solutions. Now, what about the necessity condition? The question of how do we find the simplest model? And this is the key to the whole problem. Because if we start from the assumption 4, the last one, where all rules are different, and we are only the similarities are concern only general cognitive abilities, then always when we add a language into the data set as a segment, as an additional segment, we will always have to make the model more complex by introducing all the rules that are needed all the separate rules that are needed to model that data segment. So the system satisfies the sufficiency condition, but it is extremely complex. And if in reality all languages are based on different rules, perhaps we can say that only accidentally they share rules, then the best model we can ever have is this type of complex model, extremely complex model. But this doesn't prevent researchers to try to satisfy or improve the model by making it more simple. The researcher will automatically ask, is there a way that I can improve this theory by reducing some of the independent assumptions? And as I already mentioned, if and when this happens, the linguistic community or the next generations of researchers will automatically always adopt a model that is simple than some other system. So nobody is ever moving towards, nobody is thinking that we have this beautiful and elegant theory, how can I make it more complex? This is never that occurs to anybody. So the researcher will always try to simplify. And how in this case we could do this? Well, the solution is obvious. If somebody notices that languages in this dataset, even not all, it doesn't have to concern every language, but let's say there's a huge group of languages which obey one rule of, let's say, binding, then the model can be simplified by reducing this rule from all these individual packages and assuming only one rule, which then will handle all of the relevant data in these data segments. And when we are doing this, when somebody simplifies the theory to satisfy the necessity condition by finding an underlying principle behind several languages, or perhaps all languages, then automatically this means that that component is moved from the cultural domain into the biological part. So you can see that when we try to satisfy the necessity condition, we are always moving the theory from the cultural domain or from culturally oriented theories towards the biologically oriented theories. This happens inevitably, automatically. So that's the way how this problem can be and will eventually be solved. Now I just want to make a couple of clarifications. One is that this is simply the logic. This expresses the logic of the procedure of the scientific enterprise that is involved and which will settle this question, but it doesn't tell us where the truth of this matter is. So here is how it goes. Those researchers who argue that languages are cultural objects, they are in favor of culturally oriented models. They will make the empirical claim that when we have multilingual datasets, we cannot simplify the overall theory or model by moving cultural components into the biological components. They are claiming that all of the attempts to do this will always fail. And until somebody succeeds in this type of reduction, so actually captures the properties of, let's say, a data set of containing binding expressions from 10 different languages, and different languages in a sense that they are not part of the same group even. So until we have somebody succeed in this enterprise, those who are in favor of culturally oriented theories can say that, well, you have no proof, you have no evidence that this phenomenon is of biological origin. And if they are correct in their assessment, then nobody will ever be able to accomplish a credible reduction or simplification. All the simplifications that we will find will turn out to be completely accidental, so they are restricted to few languages, and then when we add more languages, they are just completely wiped out. Their predictions don't hold true. But also the vice versa is in a sense that when researchers, let's say if researchers manage to simplify the theory by moving factors from the cultural component into the biological component, the theory becomes more simple, and they reject the cultural hypothesis by using the necessity condition. Then automatically this means it's automatically inevitable that the cultural models have to be rejected, and they will be rejected, because as I stated, that nobody will never think that, yeah, now I can make this theory more complex. Or you can do that, but nobody's gonna believe it. Nobody's paying a slightest attention anymore for that type of approach. In other words, if, and let's say also when, we find some principle or mechanism, let's just say the assembly operation itself, that can be used when modeling every language in the dataset. We simplify the model because there is only one independent assumption now, instead of positing an independent system for each language in the dataset. So let's say there is only one assembly operation, a merge operation that combines primitive elements. So then that element has to be in the biological component, and the cultural hypothesis will be rejected and proven wrong when it comes to that mechanism. So that, I think, that's what the logic of discovery will be. Now clearly, I make add one more comment. Clearly, once we start to reach a level where we know by using this logic where this line between cultural and biological approximately is, and when the community as a whole, all the stakeholders, come into some sort of agreement that, okay, we have managed to capture the properties of, say, 100 languages by assuming these biological components and these cultural components. Then we have to create also a model of the acquisition or language learning part that will be based on where the line is. The acquisition system, the language learning module, will have to fill in the cultural block by using linguistic data available for the child. So I will conclude this presentation by looking binding as a more concrete example of how all this reasoning will work. And just to summarize quickly what the binding was about, we are looking at data such as this, where the referential expressions and the core reference dependencies between them are regulated by the type of the expression. So himself will always have to refer to the subject of its own clause, examples 1 and 2. And this is a simplification, but it's sufficient for present purposes. And regular pronouns like him, examples 3 to 4, have the opposite behavior. Now the question we have to ask is then, suppose we have data like this from several languages. And now I will just show the analogous or the same constructions in how they look in Finnish. So here they are. We don't need to go into the details here, just to illustrate what type of logic we would use. So here we have sentence 1, we have a reflexive pronoun in Finnish, Pekka ihailee itseään, which has the same properties than English himself, in the sense that it has to be co-referential with the subject of its own clause. And the regular pronouns, example 3 and 4, häntä, this is a partitive form of him. It's a gender neutral, so it doesn't make a distinction between him and her, but otherwise it's the same element. We observe that Pekka ihailee häntä, the regular pronoun cannot refer to the same thing as the subject of its own clause. So Pekka and hän must refer to different person here. But in the example 4, it's possible that the pronoun is, here there's an error here, I don't correct, or actually maybe I can even correct it here at the same time. Let's fix that now so that it becomes correct. I don't know whether there was still this mistake, but this should be the vice versa. So Merja väitti, että Pekka ihailee häntä. It's possible that Merja and the pronoun häntä refer to the same person, but häntä cannot refer to the same person as the subject of its own clause, in this case Pekka. But now when we compare this data, you can see a first glimpse of a situation where there seem to be same or very similar rules behind this data I'm showing here in Finnish, and then the English data as available here. And now comes we have this dialectical situation where the culturally oriented theorist will propose a set of rules for Finnish, a different set of rules for Finnish, and then another set for the English data. And then I can come and claim that your model is too complex. You are making unnecessary assumptions. And I show, first of all, by showing examples like these, and then by constructing a model where at least some of the underlying principles are the same. A model which still calculates the data from both languages. So I show that your model is way too complex. It's unnecessarily complex. And then this automatically means that something about binding is moved from the cultural component into the biological component. But it's not enough that I show these few examples or even more examples and somehow then claim that this must be biological, that the system must have biological components in it. The researcher who is favoring the cultural-oriented model can still be doubtful and say, well, you haven't shown anything. And that's why, in order for me to argue that there's something interesting going on here that is biological in origin, I have to show that I can construct the actual model that satisfies the sufficiency condition for the multilingual dataset. That falsifies the cultural theory.